Hey, hi guys. So this is one of the final chapter of Form 1, which is Pythagoras theorem. So over here, we have an introduction. At Form 1, they introduce you because Form 2, Form 3, you will work on it. This is the basis to many other topics that will come in the future. So it's a very interesting thing, actually. And it's not that difficult, honestly. So if you know this very well, your Form 2, Form 3 will be safe. Okay? So now in your module, if you notice, I've given you this puzzle. It's a tangram. Have you heard of tangrams before? Have you done this kind of things before? Sometimes using blocks. Have you played before? Tangrams. Pernah ke? Have you? Krish, Tristan, Natasha?
Yes,
Oh, sorry, I didn't see the chat. Yes. So correct. Tangrams, okay, for you now in your module, what you can do is cut out these pieces, okay? Cut them out, all right? And try to see if you can fit all of them on this piece of paper on your left. Remember, you should not overlap. Now, what are you doing actually here? What topic do you think in maths this relates to? All right, that would be a better question.
Shapes. Triangles.
Space, a bit more specific.
Shapes. Triangles.
We don't really see triangles here.
Quadrilaterals.
Oh, okay. That's actually identifying the shapes. But again, in the topic of shapes, what exactly are we trying to do here? Fit in the what?
The blanks.
Length. Now, a bit
Length.
more. Louder. All right, actually, it's the area. If you look carefully, I'm trying to fit all these puzzle pieces into this area of this square. So precisely what we are looking at is area. You understand? It must fit in this given area. You remember what is area, right? The space inside, okay? The space inside here. All these shapes must fit inside this given area. So how do you calculate area? Quick recap. How do you calculate area, guys?
The length times width.
Times the width, okay? Or the height, whichever it is. Sometimes they call this as the dimension. If it's a 3-dimension, then you get a cuboid. Remember, okay, but we are now working with 2 dimensions, so it's a square. So the 2 dimensions that we have, you can say length and width, okay? So when you multiply the length and the width, you will get the area. Now, would you agree with me that if you calculated the area of all these pieces individually, which you can do, by the way, you have learned this, do you think if you add all these up, it would be the same number as this? What do you think? Yes or no? Put in chat. What is your guess? I repeat my question. If you added up, if you calculated the area for this rectangle, for this square, for this 1, 2, 3, 4, 5, 6 hexagon, for this square, and all this shape, you calculated the area individually. Then you added all of them up together. Do you think it's going to be the same as the area in this square, which is just the length times the width? What's your answer, Krish? Is it yes or no? Or don't know? Don't know is another option. Yes. Okay, Krish says yes. How about Tristan? What do you think? If I added all these little areas, I don't know. How about Natasha? It's okay. Never mind. Actually, I don't know. Okay, now, guys, let me ask you. If you really did this cutting out of these pieces, you cut them out, okay, and you fit all of them, it can fit, huh? What is your conclusion then? Isn't all of this the same as this then? If all these pieces can go in here, it should go in. That's what a tangram is to fit in with no overlaps. That means all these areas went into this as different pieces. So if I added all these areas, it should be the same. That is the theory. Okay, in order to do it, you need to do some practical work. That's why I've given you this in your module. You will see the first page itself is this. Okay, do give it a try later. Okay, now we are moving on. Okay, so what is this about and what has it got to do with Pythagoras? Now, who is this Pythagoras? Who? Now, he was a Greek mathematician, all right, who lived from 580 BC. I hope you know what's BC, guys. BC is before Christ, which means today the year is, we are living in 2022. Am I right? If he lived 508, make it 500 BC lah. That means you add another 500 years back in time. Okay, this year is after 0. And this year is before 0. 0 is considered a time where supposedly Christ was born. Some even say there is no existence of the year marked as 0. But never mind. Just for simplicity's sake, we assume it's like your positive, negative numbers. So you go on this side is positive. So now we are in year positive 2022. Got it? This fella lived in negative 500. That's all. So how long ago he lived? About 2,500 years plus. Got it? So he lived so long ago and he discovered this. Can you imagine how old mathematics is? Now, very little is known about his life except that he traveled a lot in his youth. Like me, this one. He eventually settled in Crotona in southern Italy, where he started teaching. Okay, perhaps I'll go there one day. Okay, he soon had a small circle of friends like you all, all right, who lived a life of study. Yeah, you guys are studying. You see, how many years ago itself people started studying? Oh my God. But they were inspired. They didn't come there forced by their parents. They came there by their own self, on their own accord. And they studied philosophy and mathematics. And they became known as the Pythagoreans. Cool, huh? And this is his stone, I think a sculpture. You see, look at the real one, and then they try to replicate a figure, but this looks much younger, this looks much older. Okay? Yes, of course. You must, if you know history, all right, very well, then you can understand that in early civilizations around this time and way before, there were already people smart enough to do a lot of maths. Okay. So now what was his discovery? Just like, okay, I'm going to ask you a question. Who discovered light? Who is the scientist that today you are using lights all over the place? Who discovered light?
Teacher, I have no idea.
Oh my God, guys. Tristan, who discovered light? This has nothing to do with maths. Hey, we got a lot of people, man. One person only discovered light, electricity. Who is it? Not electricity, it should be the light bulb. Human, Davy. Who's that? No, that's telephone. Graham Bell. Bell is telephone. Yes. The important inventors, you guys must learn. Okay, it's Thomas Alva Edison. Have you heard of him? No, so sad. And you guys use his product every day. Cannot live without electricity, light. Can you imagine? And you do not know him. So sad. Maybe I must do class for this lah.
Kita do class for sejarah.
Well, we'll see how. Okay, guys. So this guy, he worked with triangles. Now, remember what is triangle? Is it a 2D shape, 3D shape, guys? Come on.
2D shape.
What kind of shape is it? It's the first basic 3 or 2-dimensional shape that we can create. Okay, wait. Tristan, 3D must have 3 dimensions. Okay, if I add a 3rd dimension like this, then it becomes a 3D. You see that? But as on its own, we are talking about triangles. It's the first two-dimensional shape that you can create with straight lines. Oh, no, not the sculpture, darling. I'm talking about triangles, because his work, Pythagoras' work, was mainly was on triangles. Okay? And he says that the sum of angles of a triangle is equal to two right angles. Now, do you agree with that? First of all, you must agree or not. Then only we can go and learn what he has taught. Do you agree with the first statement here? That the sum of angles of a triangle is equal to two right angles. Do you know what's two right angles? Right angle is 90 degrees. So 90 degrees times 2, it's 180 degrees. Is it true that all triangles, if you total up their angles, is going to be 180? Yes, no matter what type of triangle. Now, I remember there is one lesson that we did on exploring the different types of triangle: isosceles, equilateral, right angle. Do you remember all that? Okay, this is equilateral, isosceles, right angled triangle, scalene triangle. Please, don't forget all these things. So go review back that video in case you need a refreshment. Okay. So we agree with his first philosophy, his idea. He discovered them. He proved it. Now, the second idea is what you're going to look today. Blah, 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 blah. If I read it to you now, you will not understand. And so we're going to explore this today, so you don't have to look at it right now. You get confused if you read that. Many also believe that Pythagoras discovered the dodecahedron. Okay, this is another two-dimensional shape. Okay, if you know your polygons notes, you will find this word there. They believe that he discovered it. So these are all the important things that this guy did. Okay, so let's move on and see what this is. This is what today we are going to know, or to be known as the Pythagoras theorem, this part. Okay, so this is what it is. So let's go. First of all, are you interested in learning about this guy, or do you feel like that? Can I have a thumbs up if you guys are okay? This sounds interesting. Let's go. All right. Good. And if you like history, naturally, you might like maths as well. Okay, now I give you a story. Don't read, you'll get confused. Okay, let me just tell you. All right, a simple story here. Oh, yes, darling. I'm working on that, Natasha. Okay, so you may have your wish come true. Oh, really? I see. Okay, after this, I'll talk to you all. Okay, so come back to our maths here. Okay, so here we have, can you see this farm? You have a farm, and your farm is in the shape of this triangle. All right, apparently it does look like a right angle triangle lah, okay? So we also say, okay, fine, this is a right angle triangle. All right. And you have goats, you have many, many goats. Your goats are all fenced up in this farm. Okay, you don't let your goats go out. It's all fenced up. And you got a little door lah. At every point here, you got a door. What is this green thing? Is all the field, the grazing field that your goats can go to graze. You know what's graze, right? Good makan, okay? All right. So, this is field 1. Now, if you look at field 1 carefully, it is the same as this length, or this side of the farm, and it is a square. You know what's a square, guys? I hope you know what's a square. You remember? Both sides are the same. So this is 5 meters, then this is also 5 meters. Got it? Assuming lah, it's 5. Now, on this side of the farm, okay, this other side of your triangular farm, you have field 2. Now, again, this is also a square. I cannot use the same symbol because that means it's 5. So I use this double symbol. Maybe this is 7 meters. So everything is 7 meters, 7 by 7. And on this side of your farm, okay, you have the third door. And again, you have this field here, the field 3. Okay. All right. Now, And it is also a square. So if this is 10 meters, this is also 10. Do you understand so far the story? Okay. This is your field. Okay, there are 3 fields here, and this is your farm. Your goats are here. My question is, first question, which farm will you take your goats to go to graze? Will it be field 1, field 2, or field 3? Which one will you choose to go to? Field 3. You all choose field 3. Why? Because it's obviously, it's the largest. Correct or not? Okay. Now I change story a little bit. I tell you that you got to make a choice. You can either go to field 1 and 2, or you can go to field 3. Now, if you got a choice to pick these 2 together, now you have 2, 2 fields to go, or you just go to this 1 field only. Which one will you choose? Krish says he will choose the double field. He'll choose 1 and 2. How about you, Natasha? You got no right and wrong. You guys answer only, okay? Make a choice. Krish says he will go with 1 and 2. How about Tristan? Also 1 and 2. Okay, can I have your reason? Why did you choose 1 and 2? Do you think it's going to be bigger than 3? Is that the reason? Because field 3 will be eaten by... No. Don't give that. I mean, it's okay. Nah. More dimension and less boring shape. Wow, you're thinking about creativity for your goats, huh? Not bad, Tristan. You can be a good goat herder. Your goats will have fun with you. All right. Okay. Did anyone think that if I went to field 1 and field 2, I will have more grass? Do you think so? No. You give me other ideas, like, they can play around, they can run around. You guys are all in the creative side of life, which is good. Yeah, Natasha, you think that they're going to get more field, more grass here with 1 and 2? Krish says, same amount. Natasha says, she's thinking, guys, this is your theorem Pythagoras. Now, Mr. Pythagoras says what? You know what he says? He says that, okay, let me erase and make it a bit beautiful, okay? He says that the area of this and the area of this field, the field 1 and 2, if I combine it, if I add it, it's going to be the same as field 3. It's not going to be more, it's not going to be less. It's going to be exactly the same. That's what he says. What, do you understand or not? He's telling you that the field 1 plus the field 2 area. Again, what is he telling? The area. How do you find area for a square, darlings? You remember how to find area for a square? If this is a square and this is 5, how do you find the area? What's your answer? How do you find the area, Tristan? Put your answer. What's the area for this? Length times height. Okay, now the length is 5. Height is also 5. So what's the area? Very good. It's 25. Am I right? 25. If this is meter, then it will be this is meter squared. Good. Now, what if instead of writing a number, I gave an unknown, for example, like A. Okay, so this is A. So how to find the area? If it's an unknown, any number, if it's 5, you take 5 times 5. It's 6, you take 6 times 6. So if it's A, what do you do? The area is A times A. Am I right? And you have learned this. Index numbers, A squared. Remember? Do you remember your squares? If it's A times A times A, then it's called A cube. That's right. That is volume lah. In index numbers, the one can go up many more. But anyways, let's go back to this. We just want area of a square. You remember that. We are working with squares here. The fields are all squares. Can you see? All these fields are squares. They are not rectangles. If this is the length of this side, then this is also the same. So if this is B, then the field 2 is B squared. Do you agree? If this is A, then field 1 is A squared. Do you agree? Can I have a thumbs up if you agree? The area of field 2 is B squared. The area of field 1 is A squared. So, what is the area of field 3, which I will put it as C? If I put this as C, this length as C, then what is the area of field 3? C times C, which is C squared. Got it? And according to smart Mr. Pythagoras, what did he say? The area for field 1 plus the area for field 2 is the same as the area of field 3. So what he's literally saying is A squared plus B squared is equals to C squared. Got it? There you go. That's the Pythagoras theorem. Do you understand now? So don't simply learn things. The teacher told me this already. Teacher has to remember. No. You understand what's happening behind. Where is this square coming from? The square is actually a square. It's imagine a field behind the length of that triangle. So that's why the story of the farm and the goats and the field and everything. Just to get you this idea of A squared plus B squared is equals to C squared. Do you understand now where this is coming from? So now we are going to work with that formula. Okay? Okay, I'm going to skip this. It is not, this one will be, okay. So here on your second page of your module, guys, you will have this. If you look at your module, you have this same thing, the field there. Okay? And you can actually, just like the tangram that we did, you remember the tangram we did earlier? We cut out the pieces and you're supposed to put on another piece and the area is supposed to fit. In the same way, you can actually prove this theorem Pythagoras by cutting out this field. Remember the A field, the A side, and then this is the B side, the B field. Okay, the grazing field. Remember this is your goat, your triangle here, and this is supposed to be the C field. So you cut out this square, you cut out this square, and you can actually fit it in this bigger square. However, you cannot simply cut it out as a square. You got to cut it a bit differently. Okay, but the area is still the same. You are not adding anything to it. So you see those lines there? Can you see those lines forming there? These are diagonals. Now, all you need to do is in your module, I have given you an extra line there. Can you see this extra line? This, okay, let me make it a bit bigger. Maybe you can see. I cannot make it bigger. Guys, can you see this line here? On your module, you will see this line here. Okay, and you will see also another straight line here. You take your scissors and cut this shape out, this field. Okay, you cut this field out. Okay, you cut this shape out and you also cut it along these lines, not the dotted lines, but the straight lines. You also cut out this square. You also cut it out. Now, what do you have? You will have a square, okay, and you will have 1, 2, 3, 4 pieces. That's exactly like your tangram. And you try to fit all these 5 pieces into this. And that proves that the area and this area for this square is the total. When you add them up, it's going to be the same as for this square. And I will also show it to you visually here. The doing part, you do later. Can you see? You'll get 5 pieces like this. You'll get that main square from A, and then the B is cut out like this. Like tangram pieces, you know, like the tangram blocks. But instead, it's just a piece of paper. Now, what do? You will arrange it. You see, you arrange it like that. You try to fit it in, and you see how it goes? It will fit in exactly. Did you guys see that? Nampak tak? You want me to repeat it? Okay. Yeah, I repeat that video again. So watch. This one is the first, the area from the small square, the A square. Okay. And these are all the 4 pieces from the B side. You see how it fits in onto your C square. Okay. So look very carefully. So take your A, go put it somewhere in the center. Then all the other pieces goes around it. So this proves, this is what this guy did lah. He proved it. That's why he's remembered and we learn him today in our books. Too bad lah, he's too smart, right? Okay. So here, we now really officially come to the Pythagoras theorem. Now you see this back to your farm, okay? Your A side, your B side, and your C side. Do I make sense now? Now, what does A square means? A times A. So the area of the square here, okay, plus the B squared, B times B, which means there is another field here, a square, so I can't draw further. And that's equivalent to C times C, C squared. And you could actually do a hands-on experiment by cutting these shapes up and putting it here. All right, and that's your Pythagoras theorem. What's your Pythagoras theorem? A squared plus B squared equals to C squared. However, there is one thing you must remember. This rule is only for a certain type of triangle. You remember there are many types of triangle, huh? Now, which type of triangle is that? Make a guess. Is it scalene triangle? Is it isosceles triangle? You must know that this only works for a right-angled triangle. No others. Okay, the Pythagoras theorem is not to be applied. You don't have to do it with other triangles. It's only for a right-angled triangle. So this is an important thing you got to keep in mind. And then remember, A squared plus B squared is going to give you C squared. So what is the question? The question is, I'm going to ask you to find all these. For example, the question will give you the value of A. The question will give you the length of B. The question will ask you, what's the length of C? Or the question will give you C. The question will give you B and ask you to find A. Or the question will give you A, the question will give you C and ask you to find B. Do you understand what I'm talking? They will give you any two angles or sides and ask you to find the other. Do you think that's going to be that complicated, honestly? No, it's not. Let's look at the questions, okay? So I don't want to do this. Let's skip this fellow. Okay, now we go to questions, all right? Let's go really see some questions. So far, so good. That was an introduction. How do you feel about Pythagoras now? You think you can do him? Do him pula. What do you think, guys? So far, so good. You like it or not? I like it. Pythagoras was one of my favorites. Can lah. Okay. So now, Now we're going to look into this, calculating the length of the longest side. You remember now I told you there was A side, B side, C side. Not C side. C side, okay? There was like, guys, okay, A side, B side, and C side of the triangle. Which do you think is the longest? C side. Which do you think is the longest? C. Okay, and do you know there is a special name for it? The C has a special name because it is the longest side. You don't call it seaside. It's not the beach, seaside, okay? It's the hypotenuse, okay? That's the name for it. So let's look at it, okay? All right. Okay, so recall the Pythagoras theorem. Can we do that? A squared plus B squared is A squared plus B squared equals to C squared. Now identify the hypotenuse. Now, which is the hypotenuse? If I give you any triangle, a right angle triangle, okay? In fact, any triangle also, but it's suitable for, it is definitely for a right angle triangle. And then finally use the Pythagoras theorem to find the length of the hypotenuse. So you will be given A, you will be given B. You got to find what is C. Do you understand now what we are doing here? The very, very long side. Okay, good. So let's move on to some examples. Okay. Before we go to examples, take out your calculator or if not, use your brains. What is the square root of 25? This is a revision from one of your earlier chapters in, remember squares and roots, that chapter? Okay, put in chat now. Good, very good. Next question. What is the square root of 36? 6, good. Square root of 49? 7. Square root of 100? 10, good. 196. Tekan your calculator. 14. Okay. 225. 15, very good. Important numbers must remember. 400. 400, no, Tristan, check it back again. It should be 20. Okay. 256. 16, good. 50, okay, now you're going to get weirdo numbers. 10, wait, where did you get 10 all, Kristen? Which one are you answering? Are you answering number 4? Okay, I'm at number 9 now, guys. Okay, we are at number 9. Okay, hold on. Number 9. So when you put your answer in the chat, darlings, you do like this. You put 9, you put dot, and then you put your answer. Okay, then I know you're answering number 9. Because your answer is lari and then. Okay. So what is the answer for number 9? Square root of 50. Now this one you have to tekan the calculator and you will have a decimal number. You look at the question, round off to 1 decimal place. I only want 1 decimal place. So Krish, 7.07. I will round it up to 1 decimal place. No, 7.1. That's right. Okay, it will be 7.1. How about 12? Number 10. Sorry, how about number 10? The square root of 12. Hey, all this is easy. You have to just use your calculator and do this. 3.5. Now, if you notice, you have decimal numbers. Okay, let me just hold on. What is square root of 9? It's 3. Am I right? What is square root of 16? It is 4. So any numbers between 9 and 16, for example, square root of 10, square root of 11, square root of 12, any number from square root 10 to 11 to 12 to 13 to 14 to 15 will all be between 3 to 4. That means it can be 3.1, 3.3, 3.4. Do you understand? It won't be more than 4 because the square root of 4 is already, because 4 is the square root of 16. Do you understand? So if you tell me the square root of 12, It's 3.5. Yes, very logical. It's between 3 and 4. Now let's try this. Tekan in your calculator square root of 14. What do you get? Press in your calculator square root of 14. What do you get? 3.741. Can you see that? So it will fall between this range of numbers. Okay, so now you understand this. Please do this. In fact, it's in your module. These questions are there. Okay. Now, come look at number 17 here. If your answer is 7, what answer would be inside here? Number 17. If 7, you square root a number, you get 7. What number is it? Very good. It's 49. Okay, if answer is 9, what number is inside here? 81. Good. So what you're doing is you're squaring up. Am I right? 3 squared. So this should be 9. So square root of 9, back to 3. 8 squared, it's 64. Square root of 64, back to 8. Do you understand? Now this is from your earlier chapters and it links up very much with Pythagoras. Why? Because just now you want to find area. Remember, if this is A and this is a square, so A and A is the same length. So the area is A squared. That's why you got to come back and revise all this. If not, you'll get a bit lost. Okay? Can you do this? Do you understand? Can we go on now to the next slide? Boleh? So, this one is the answers. So let's skip this. Okay. So remember these, according to Mr. Pythagoras, the A side of the field, if I square it, I add it with the B side of the field, it's going to be equals to C side. C squared, okay? Excuse me. Clearing my throat. Now look, here comes the triangle. Here comes our A side. Here comes our B side and the C side. This is the hypotenuse. And so C is the longest side. And how do you find the C? It's always found opposite the right angle. See, your right angle is here, guys. If you are standing here, opposite you is the C. Okay? This is opposite. Now, learn these words, okay? Because it will be important later. Opposite is important. And if it's at the side, like A and B, it's at the side, right? Beside you, the word is adjacent. I think so. This is the spelling. Yes, adjacent. Okay. So there's two words here, opposite and adjacent. Okay. You just improve your vocabulary. A is adjacent from the right angle. It's adjacent. B is adjacent. C is opposite. Okay. Enough. Clear. And let's see how to find the side according to the Pythagoras theorem. Again, another triangle. A is here, B is here, C is the longest side. It's opposite to the right angle. I just turned the triangle only. So you just also turn your mind. Okay? Next. All right, now we apply the formula. Okay, guys, now the maths part comes. If one is 6 cm, the other is 8 cm, how do I find C? Do you understand? This is 6 cm. This is 8 cm. How do I find the length of C? So, how do you do this? First, you take 6 squared. This is A, right? So, A must be A squared. So, 6 squared. You plus that answer with 8 squared. And you will get C squared. Okay? Don't go and just cancel the 2. It doesn't work like that. Okay? You work out the calculation. 36 plus 64. And that's equivalent to C squared. Now, what is 36 plus 64, guys? It's 100. And 100 is equivalent to C squared. How do I find C? That means what times what gave me 100? What I need to do is find the square root of 100. So tekan in your calculator, what is square root of 100? 10. So the length of C is 10 centimeters. Got it? You just did. You just solved the length of finding the hypotenuse, the C side, by using the Pythagoras theorem. And that's all there is. Not that bad, not that difficult. Is it difficult? Isn't it? It's not. So enough, I already explained already, okay? Okay. Now, how do you summarize or how do you remember it? An easy way, huh? Square, square, add square root. Just say it again and again. Square, square, add the two answers like just now. 36, 6 squared is 36, square it. 8 squared is 64. Then you add, you get 100. And then what do you do with the 100? You square root it. And your answer gets to 10. So it's an easy way to remember. Square, square, add square root. But if you understood the field diagram earlier, this is nothing. Am I right? You can already remember this for life. Let me share with you a story. When I went for my teacher training interview, that was way after I finished my schooling. Okay, I learned this all in school. Okay, then finish degree, finish the teacher, wanted to go for teacher training. So go for interview. You know what the first question they asked me? How will you teach Theorem Pythagoras to your students? So I had to remember, and luckily I remembered it . So I thought, but I didn't teach this way . I don't know what way I thought 20 years ago. Okay, to that one person who interviewed me. Okay, but I got the teaching job after that. All right, so that was just, something. Okay, let's go to the question here. So this is your A side. Okay, remember, this is your B side. And this is your C side. Yeah, 20 years. Yeah, 20 years plus already I've been teaching. What? Okay, this is your C side, your hypotenuse. So A squared, 5 squared, plus B squared, 10 squared. Okay, what's the answer? Here it's 25 and here it's 100. So it's 125. Am I right? And to find C, I have got to square root this 125. And what is the square root of 125? Can you tekan in your calculator? $12. Betul ke? No lah, not 12. Don't round off. 11.2. Round it off to one decimal place. Because 12 is 144. Do you understand? Don't round off the whole number. Only round off to one decimal place. Huh? Okay? All right. Don't round off to the whole number because that won't be accurate. All right. So one decimal place. Okay? Because you must understand the square root of 144 only, you will get 12. You understand? Only 12 will only come in for a square root of 144. And 11 comes from the square root of 121. So any number between 121 to 144, like 125, will be 11 point something, something, something. It won't reach 12. Do you understand? Thus, the importance of keeping to a decimal number. Again, it really depends on your question. If the question say use 2 decimal place, then you use 2 decimal places. Like 11 point, what's the original answer? 18. Okay? If the question says use 1 decimal place, then you can just use 1 decimal place. Understood? Okay, can we move on? So already found this already. Okay. Okay, done. Okay, calculate the length of C. Guys, now you guys try it out on your own. Tell me what is the length of C. First, okay, probably you guys already know. Okay, I give you a minute. Put in the chat, what is your C? Oh my God, I forgot to recording. So much missed. That's why I never like to pause the recording. Okay. So many things have missed out already. Oh God. Okay, while you all do this, I'll do a quick recap. Okay, guys. Okay. So for the sake of the recording, we found it now. Now we're going to find, okay, assuming now we all know that this is A side. Okay, this is B side. To find the C side, which is the longest, we take A squared plus B squared. You will find C squared. However, in some instances, okay, the C is given, the A is given, and they ask you to find the B. Or the C is given, the B is given, the B side is given, they ask you to find the A. And in whichever case, all right, earlier we added the two shorter sides to get to the longer side. So the operation now reverses to subtraction, in which we take the longest side and subtract. Okay, so let's go to the slide. While you guys answer it, I'm just explaining here. Oh, hold on, 1 minute. Okay, so here, if you want to find the A side, then you take your C squared minus the B side, you get your A side. Or the other shorter side, they've given you C side and A side, you find the B side. You take the hypotenuse and you minus the shorter side. Okay, let's go to the question now that you have been doing. We have done a few examples. Is it this one or this one? Your turn. I think your turn was this question. Okay, so you guys are doing this. You can see the hypotenuse is 12 and A side here is 3. You're supposed to find B side. So the longest side, C side, will minus C squared, will minus A squared here to give you the answer for B squared. So 12 squared will minus with 3 squared to give you the answer for B squared. 12 squared is 144. 3 squared is 9. And that will be the answer for B squared. Find it, okay, in your calculator. 144 minus 9 is 135. So then what is the square root of 135 to 1 decimal place value? What is your answer, guys? 11.6. Okay, possible. Okay, 11.6. Well done. So clear? Do you understand now how to find the other side, whether it's A or B? But given to you the longest side. So don't go and add, play around with the theorem. Earlier, A plus B will give you C. Now, if you're going to find B, you've got to take C minus this. That's the whole logic there. Okay, but it's all in squared. That's all. Okay, so let's look at, I think one of the last slides already. Okay. Okay lah. Boleh lah. All right, guys. That's about it for Pythagoras theorem on the PowerPoint slides. Now we will look at your module. Okay, I will have a quick go through your module because I think you can then do all the questions there already. So, can you see the screen on your side? The module? Nampak? There's only 7 pages here. 7 pages only. Most of the time we do more than 7. But yeah, that's about it. So guys, the first part is you remember this, the tangrams. So cut them out, do explore. Okay, this will be your first activity. Try to fit it in. And then proving the Pythagoras theorem. So over here, you cut this piece out. Okay, you cut this fella out. This is your A side, and this is your B side. Now, where do you cut? You cut on this line. Don't cut on the dotted lines. The dotted are diagonals. You cut on this line, you'll get 4 pieces, and you can put them all together here on the C side, proving to you that A squared plus B squared is equivalent to C squared. I want to ask you a question here. Did any of your teachers in school actually do this with you? Experiment it this way? Anyone? 3 of you are here lah. Put in chat. Ada ke? Tristan says no. How about Natasha? Nope. How about Krish? Did your teacher do this? Your speedy PD LRT teacher? No. You see, guys, sometimes it's very important to experiment with things. Okay? If you really do this exercise, you will remember for the rest of your life. You will not forget Pythagoras theorem. You understand or not? My primary, oh, that's good. She did teach you Pythagoras theorem. Oh, really? You guys you did this in primary? This exact thing? But how come it is in primary syllabus, huh? It shouldn't be, right? Wow, your teacher is good. That one is really good. Okay? All right. Good. That's a good teacher. All right? Support. Okay. Guys, so do explore this. All right? And what do we have after that? You remember this? You did the squares and the square roots. You know, it's a bit of a recap practice. So I believe you can do this one as well. Use your calculator. And this one, no need to use calculator. This one can use. Okay. And even it involves decimal numbers. Remember 2.5 squared. Okay. Then you have the questions. Now tell me, are you confident to do this now? Can you do? Don't forget about the numbering now, okay? Just imagine this is 1, 2, 3, and 4. Okay? There are 4 questions here. Do you think you can do it? You can find X or not. X is the hypotenuse. We have done a couple of questions already. Kan? Yes, boleh. Tristan says good. Okay, good. Then, what else do we have? This one, over here at the bottom, okay, 1, 2, 3, 4. I'm just changing the numbers here, guys. This is question 5 and make this question 6. Finding the other side. Finding the other side. This also now we have learned. 7 squared minus 3 squared gives you x squared. Got it? 6 squared minus 5 squared will give you x squared. Can do? Can I have a thumbs up if you can do this? Can attempt? Okay, 1, 2, 3, 4, 5, 6. Senang, huh? Okay, then 7 and 8 again. Finding the other side of the triangle. However, the problem is, if I teach you like that, can. And then I go on to, okay, let me explain again. These questions that you see, like finding it straight. This is called band 3. What is band 3? Applying the knowledge that you have learned. So what is band 1 here? Band 1 here is remembering the Pythagoras theorem. A squared plus B squared is equals to C squared. That's remembering. Do you understand now, band 1? And then, understanding it. You remember the field experiment we did. That's understanding. Now, band 3 is applying that knowledge. Yeah, now you can apply already. You can find it. This is band 3. Now, you come to band 4. Where? Here. Can you see these wordy questions? That's band 4. You are analyzing the question now. After that, I did put in some questions that were from your textbook. And I know, maybe in the beginning, it may be like, wow, the textbook question is like so hard. But trust me, if you really, really understood it very well, that's not a problem. Okay, so I'm going to go explain. We're going to go and look at question 6, guys, because I think the others you can do. Okay, so clear? Let's go to question 6. It's a word problem. Okay. If a right-angled triangle, so when they come up with stories like this, the first thing you do, you take your pencil and you start drawing with a ruler. Just draw it out, guys. You know, just draw it out. Okay, make your life easy. If a right-angled triangle has short lengths of this and this, short length, that means this is 4, one of the side is 4, the other side is 10. Find the length of the longest side, the hypotenuse, the C, the longest side. Round off your answer to 1 decimal. Guys, yeah, you can do this or not? Tell me. It's just worded, but you must again find only the longest side. Can I have a thumbs up if you can understand this now and do it? Yes, this is band 4. Okay? All right? Clear? Let's go to question 7. See, I'm not going to feed you answers here, guys. You got to do it finally, okay? But I'm just showing you the push start button there, okay? Now, what is this story here? What is this story telling? A boat travels, okay, story, huh? A boat travels 45 miles east. So, guys, your geography here. Where is east? East is this way. Am I right? Going this way is east. So, a boat travels 45 miles to the east and then 60 miles to the north. Okay, so now I clear my drawing. I put here 45 miles to the east. This is my east. And then 60 miles to the north. This is north. Can you see that? Put in your numbers. This is 45 miles. Okay, not meters, huh? And the other one is 60 miles. You draw it according to the description. Question is asking you, how far is it from where it started if you were to draw a straight line? Remember, if you want to go from one place to another place, okay, if you want to go this way and then go this way, you will take the long route. The shortest route is always going to be the hypotenuse. Do you understand? It's always going to be shorter than this and this added together. All right, I'm not talking about theorem Pythagoras. I'm just talking about length here. All right, this is length. Teacher, I learn in BM, I don't know in English. Hey, Tristan, your school teaching in English with maths. Oh, geography. Oh my gosh. Hey, east, west, all you don't know. Like, that's easy, guys. Okay, east, west, north, south. Okay, go look out at the sun. The sun rises in the east. Okay, all right. Okay, so the shortest route would be from where that ship started to where that ship is right now. You are going to find the seaside, the hypotenuse of this triangle. Remember, this is a right angle because on the compass, this is your east, this is your west, this is your north, and this is your south. Trust me, for this chapter, you need to integrate this knowledge. Okay, this is a basic knowledge that will come in for many questions here. All right. So can you then find the seaside? Because it's 45 squared plus 60 squared. It's going to give you c squared. Then find the square root. Back to Theorem Pythagoras. Got it? Can do? Give me a thumbs up. Boleh? All right. Now, next. This is from textbook. Okay? All right. Look at this. I'm not gonna answer everything. Just look. Explain only. In the diagram, PQSU is a rectangle. So where is P? Q, S, U. Fine, I understood. Calculate the perimeter of the shaded region. Where did perimeter come in suddenly? We are learning Pythagoras. Guys, anything can come anywhere. That's maths. Okay? So you want to find perimeter of the shaded region. Okay, perimeters go around. I have 11 here, but 11 is from here to here, guys. Remember? Because the full one is 17. Got it? Then this one is 12. So, okay, perimeter, I got one side, two side, three side. This one is 4. Good, fine. But I've got to find this fellow here. How much is this one? Can you see? Now, can you see that this is also a right angle triangle? So what I literally need to do is draw it out. Okay, draw it out. So I'm going to draw this empty box part. Of course, it's a right angle triangle. And we have to find what is this. in order to find the perimeter. Now, if you want to find this, you must know the A side and the B side. Now, from your picture here, can you figure out how much is this? Can. 17 minus 11. Can you see that? 17 minus 11, and how much is that? It's 6. How much is this? How much is this side? How about this side? It's 12 minus 4, and which is 8. So now, 6, 8. If you do not know your Pythagoras triple, those things, then you can do the normal theorem. This is a Pythagoras question now. To find this, 6 squared plus 8 squared. And what is that? 36 plus 64. And that gives you 100. Square root of 100 is 10. So what is this side now? 10. You remember the Pythagoras triple? 6, 8, 10. That's another triple. So now you have this. Can you now find the perimeter? Can. Do you understand this question, Tristan, now? So that's how you do. But of course, you must write it out, lah. Okay? But the first part is finding this. To find this, you must know what is this side, and you must know what is this side. How do you get this side? 17 is the whole. You minus with 11. And you get here 6. To get this side, you take 12, which is the whole length here, and minus 4, and you get 8. Finally, you're working with the Pythagorean right-angled triangle, and you can do calculate the answer to find the hypotenuse, which is now 10. Then only you get on to finding the perimeter. What band is this? Band 4? It can even be categorized as band 5 because it has got 2 different things that you are doing. Okay? Now I understand. It's okay. See, if you understood what is Pythagoras theorem, then it's just about that. It's not that too difficult a thing also, kan? Okay, understanding is the most important thing. Now the ship story. For this, you surely need to know your compass. Okay, so again, north, east, south, west. North, east, south, and west. Remember, okay, that's how it goes. A ship is at 34 kilometers north of ship B. So ship A is north of ship B. So you put this must be B, and maybe this is A because it says north. So north is exactly a straight line. Okay, north means here north. Okay, so A is north of B, and what's the distance? 34. Okay, I'm not putting the units. I just want the number. Ship C is at 10 kilometers west of ship A. So if this is A, where is the west? West is here. Can you see? West is here. So what I need to do? Straight line. And this is the location of ship C. Now I'm like a navigator. Then that is 10 kilometers. So this fella is now 10. Calculate the distance between ship B and C. Can you see what am I doing here? Finding for a distance from B to C. If you ever be a captain, you're surely going to use all these. What's this? Now can you see it is a triangle? Then you use your knowledge of Pythagoras and find the hypotenuse. And give it to 2 decimal places. Understood? Can I have a thumbs up? If you can understand that question. Okay. All right. Draw. You need to literally draw. All right. Your brain sees better. Why God give you eyes for what then? To look, right? So draw and have a look at the ship. Okay. Clear. All right. Next question. In the diagram, PQR is a straight line. Okay, fine. Calculate the length of QR. they want you to calculate what is QR. So PQ is 30. This one is 34. PS is 34. And then QS you don't know, but SR is 20. Can you see there are two triangles here? So the first triangle, if you want to find what is QR, this is what you're going to find, you can. But you must know what is QS. Then you can take 20 squared and minus QS squared and you can get this fellow. But you don't even know what is this. However, you can find out what is this because they have given you the other two sides for the other triangle. Do you understand now? It's a double usage of your Pythagoras theorem. Double application. So the first step is you want to find QS. And to find QS, you take your 34, your hypotenuse, 34 centimeter squared and minus with the 30 centimeter squared. All right. And then you will get something. And you square that answer and you will get QS. Got it? Now to find QR, you got to do the same thing again. This is your hypotenuse now. So you take 20 squared and you minus the QS squared. And then you will get an answer and you square root that answer and you will get QR. Do you understand this question? It's a double theorem Pythagoras at work. To find QR, you must find QS first. To find QS, you use the theorem Pythagoras, you minus. Then to find QR, you do again the same thing. You remember finding the shorter side? Earlier we did. Okay. How do you find the questions? Now in your textbook, it's doable. Okay. All right. Last three questions. All right. I'm going to make it a bit fast, guys. In the diagram, PQR and RST are straight lines. Okay lah. Where is PQR? PQR. RST. Okay, good. This is 12. This is 3. This is 5. This is 13. Do you remember the triple Pythagorean, the earlier ones that you learned? 3, and this will be surely 4 and 5. Now, if you don't believe me, you can go. Take 5 squared minus 3 squared. 25 minus 9. What do you get? 16. Square it up, it's 4. Got it? So you already found what is RS. RS is 4. So what is this fellow? ST. If RS is 4, ST, look at ST, this length. It must be 12 minus 4. So you see that you find that angle, that side first, and then you can find what is ST. Because you're going to find perimeter. I didn't even read the question. You're supposed to find the perimeter. So now how about this one? How much is this? How about QP? How do I find QP? Very simple. Look, again, there is a triangle here. So 13 squared. 13 squared, you must minus with 12 squared. Okay, and I think this would be how much? What is, guys? Let's do this. What is 13 squared minus 5 squared? 12 squared, sorry. 13 times 13 is 169 minus 144. Ah, it's 25. I knew it was a triple. 25. And what is the square root of 25? It's 5. So this fellow is 5. And if it's here, it's 3. That means here, it's 2. So now you can have the perimeter. You know what's perimeter, right? You go around. Okay. Do you understand this question now? Good. It's not that difficult. It's just that it has more than one step. It has two to three steps in it. Okay. If you look earlier, okay, the first thing I clear, the first step here is finding RS. using Theorem Pythagoras. Then the second step is finding this QP. And to find QP, first you needed to find RP. And again, you use the Theorem Pythagoras. Then you minus the 3 and you find QP. And then only you can find the perimeter. That's why the questions get complicated. Because there are multiple steps before you can get to the answer. But you must have the ability to look inside, to study. This is called analyzing. And this is band 5 lah. Okay? All right? Understood? Okay. Now, again, this one I think is not that difficult. One end of a rope of length 7.2 meters, okay, is tied to the tip of a flagpole because they give you pictures some more. Okay, the other end of the rope is tied to a spot here on the horizontal ground 4.5 meters away. Now, if they just gave you the story, then you must draw it out. Since they gave you the drawing, it makes it easier. Calculate the height of the flagpole. Can do lah. Square root minus square root. Got it? And you get this. This is Theorem Pythagoras. Okay, this is your right angle there. Someone they give you a picture there. So, easy. This one, band 4. Why band 4? Because it's still worded. You see that? Band 4. But it's worded. And it's just one simple step. It's just finding the side. That's it. Easy. Now, last one. Sailor, sailor. Shipping story. A ship departs from point O. So, put your O here. And sails towards southwest. Oh gosh, now you know where is north, south, east, and west. So the fella, southwest is here, darlings. Okay, this is southwest. Not so easy now. So now we want to draw a line that goes southwest. So like that. Okay, for a distance of 300 kilometers. So put lah 300 kilometers. And then towards northwest. Mana pula northwest? Northwest. Now this is north. This is northwest. So go on here. Northwest. For another 450 kilometers. So 450. Now remember, between this northwest and the southwest, the angle is 90. Because every angle here is still 90. So between southwest and northwest, you tilt it. If you look at it, it is 90 degrees. So yes, this will be 90 degrees. Now you're looking like a triangle, not Titanic. Oh my God. Calculate the final distance of the ship from point O. So this was your point O. And then all you need to do is connect the distance here. And you get a triangle and you find your longest side. These kind of questions, you need to draw it, imagine it, and draw it out accurately. Then it's doable already. Got it? Clear? That's all. Habis. Your Theorem Pythagoras. Okay, there's one little point lah. I think in one of those textbook questions there, the last part, but I think it's all right. Okay, if you have time, we can go through it next time. Okay? And if you understood your Theorem Pythagoras, it's not that difficult then. Okay. So, any questions so far? So 1.5 hours. Okay. Stop recording. Okay.